Okay, welcome back. This is the video for Math 126, section 10.7. 10.7 is partial fraction decomposition, and it's something that will kind of disappear after this course until you get back until you get into calculus. So you'll see it there. So there's only a couple of problems on the homework, so let's take a look at a few of them. I didn't write down which one this is. I believe it's number 1. Maybe. Might be 2. It's either 1 or 2. But let's take a look at it. It is 9 over x minus 3 times x plus 6. Right? And the idea on partial fraction decomposition is to take a fraction, right, some fraction that looks like this, where the denominator has factors, and turning it into the smaller pieces that were added, right, before we had it in a common denominator, so to speak, right? So this is going to turn into some number over the one factor of x minus 3, and then added to some number over the factor of x plus 6. Right? If we started on the right hand side, we would get a common denominator and turn it into the left hand side. We're just going backwards now. We're taking something that has this already common denominator and breaking it down into its parts. Right? So I have this as my equation that I'm going to deal with through this problem. What I want to do is clear the fractions, right? So I'm going to multiply everything by x minus 3 and x plus 6. So that is to say I'm going to multiply this by x minus 3 and x plus 6. This one by x minus 3 and x plus 6. And this one by x minus 3 and x plus 6. Right. When I do that, the x minus 3 cancels the x minus 3, and the x plus 6 cancels the x plus 6 on the left hand side. That leaves me with just a 9. On the right hand side with my fraction with a, the x minus 3 cancels the x minus 3, and it just leaves me with a times x plus 6. And then the x plus 6 cancels with the x plus 6. That leaves me with b multiplied by x minus 3. So this equation, in order for the top to have been true, the equation that I have now has to be true for every single possible value of x. It has to be true everywhere. And so what I'm going to do is choose some nice, I call them convenient values of x, that are just going to make this work out pretty well. My first convenient value of x is going to be x equals negative 6, specifically so that I can make this factor right here cancel out. So if x is negative 6, then my equation is 9 equals, but negative 6 plus 6 is 0. This whole term is gone. I'm just left with this negative 6 minus 3, which is negative 9, times the b. And it's easy enough to see if I divide by negative 9, that b is 1, negative 1. Okay. So I'm going to write that up in the corner and then erase this because I need some more room to figure out what a is. So b is negative 1. Okay. And in fact, I only need to erase, in fact, you know what, I'm not going to erase anything. I can fit this right here. The other convenient value of x is if x is equal to 3. And if x is equal to 3, 3 minus 3 is 0. Now this term goes to 0, leaving this term. So I'll do that. X equals 3. What happens then? Well, then I still have 9 on the left-hand side. Equals 3 plus 6 is 9, so I have 9 times a. But then this other guy is gone, so again, it's pretty quick and easy to see that a is 1. Okay. And I've solved it, right? In the end, I wanted it to look like this, a over x minus 3 plus b over x plus 6. I have a and I have b, so in the end, my final answer is replace a with 1. Replace b with -1. So I can either write -1 here, or I can pull that minus here in this case. Doesn't really matter. But I've got this, and I've got my solution. And you can check that. You can take these two fractions, get a common denominator, add them together, and you should end up with what you have on the left-hand side. All right. Let's take a look at, well, I didn't write this one down as well. I think it's number 4 though. So let's take a look at number 4, possibly number 4. This is section 10.7. Maybe 4. But it's x squared minus 3x plus 5 over x minus 3 squared times x plus 2. Right? And the first thing that it asks you is how this thing is going to be broken down. Right? And whenever you have a factor that's squared, or the third power, or the fourth power, you're going to have each single possible power show up on the right hand side. So that is to say, I'm going to have x minus 3 squared. But I'll also have an x minus 3 term potentially come out. I don't need parentheses there. Okay. So if this were, say, x minus 3 to the 5th over here, I would have x minus 3 to the 5th, x minus 3 to the 4th, x minus 3 to the 3rd, and so on and so on and so on. And each of these is just going to have some constant term over it. And then I just have this x plus 2 with some constant term over it. Right? And that choice, I think, was choice C when it pulls down and says which, form is this in. That's it. Whatever one is this, and I think it's C. Right? But again, I'm going to have to solve this, I'm going to have to clear the fractions. So I'm going to have to multiply everything by x minus 3 squared and x plus 2. So I will multiply this guy by x minus 3 squared, x plus 2. X minus 3 squared, x plus 2, x minus 3 squared, x plus 2, and x minus 3 squared, and x plus 2. Kind of short on room on the right hand side there. But the x minus 3 squared takes care of the x minus 3 squared, and the x plus 2 takes care of the x plus 2 on the left hand side, leaving me with just that polynomial. And on the right hand side, the x minus 3 squared takes care of the x minus 3 squared for the a term, so I'm just left with a times x plus 2. For the b, I only have one x minus 3 in the denominator, so it takes care of one of them, but it leaves the other one. So that leaves me with b multiplied by x minus 3 times x plus 2. And then the x plus 2 cancels out here, and that leaves me with a c multiplied by x minus 3 squared. Okay. I'm going to need the room here, so I'm going to erase most of this and take this line and just shove it up to the top. Write it in blue. Probably went too big. Okay. So I have that. Now again, I can use some convenient values of x here to figure out most of this problem. Let's do that. My convenient values here are the ones that give me zeros, so negative 2 is one of those. So if x is negative 2, okay, Then I plug in -2 in for x on the left-hand side and the right-hand side. So that is -2 gets squared, so that's 4. -3 times -2, but that's +6. And then +5 is equal to, and here I have -2 plus 2 is 0, so it cancels that one out. So that's 0. -2 here will give me -2 plus 2 is 0 times, it doesn't matter, the rest of this doesn't matter, it's 0. And so that gives me c multiplied by -2 minus 3, which is -5 squared. Right? So on the left-hand side I have 15. On the right-hand side, -5 squared is 25. So if I divide each side by 25, I get 15 over 25. Simplify that, and that gives me c is equal to a positive 3/5. Okay. And the next one I want to use is x is equal to 3. If x is equal to 3, then I have, plugging in 3, I get 3 squared is 9, but -3 times 3 is -9, so this cancels out and leaves me with just a 5 on the left-hand side. Here I've got 3 plus 2 is 5 times a, so I have 5a. The 3 minus 3 gives me a 0, so the b term cancels out. 3 minus 3 is 0, so the c term cancels out. And that's it. I've got 5 equals 5a. Divide by 5, and a is 1. And we're 2/3 the way there. I have a, I have c. I just need to figure out what b is. But I can't use this method anymore. I've used all of my nice values of 2, and -2, and 3. There are no other ways to zero out, say, the a term and the c term. And leaving the b term. It's not going to happen. Right? But like I said before, this has to be true for every single value of x, and I already happen to know what a and c are. So I can pick a good value of x, like, say, 0. If x is equal to 0, x squared is 0, 3x is 0, and I just have a 5 on the left-hand side. On the right-hand side, well, I know a, so a is 1, x is 0, so I have 1 times 0 plus 2, which is 2 times 1, so that's just 2. Right. I don't know b, that's what I'm looking for, so I have plus b multiplied by, though, 0 minus 3 is -3, 0 plus 2 is just 2, plus, I know c is 3/5, and I have x is 0, so -3 squared. Okay. And I have an equation of only one variable. I simply don't know b. So this is to say that I have 5. I'm just going to minus my 2 now, simplify a little bit as I go, and maybe not write all of my work since I have this much space left. 5 minus 2 gives me 3 on the left. -3 times 2 is -6. So that's -6b. This -3 gets squared, so that's a positive 9 times another 3 is 27. Right. So I would subtract my 27/5, right? So this 3 I can write as maybe 15/5 minus 27/5, which is -12/5. And that's equal to -6b. Both of these divisible by -6, that leaves me with b is equal to -2/5. And those would be your answers. A is 1, B is -2/5, C is 3/5, and there is a spot for D, but since there isn't a D in the formula that we had, you just throw in a 0, I think. Or it might be NA for not applicable, but I'm pretty sure it's a 0. So, hopefully that's helpful. Remember that we've got a test 3 coming up in 2 days. I'll send an email out for that, and I'll see you for the reviews.